and ECLAT.
Yeah.
Both
Yes,
ECLAT also a priori
yes,
hidden,
we
right?
have done. Yeah, we have done. Association done, and everything is done. I think we are ready for the other. Just to open that folder structure because I don't have right now.
Yeah. So this reinforcement learning, after
Hmm.
association learning, the reinforcement learning is going to start.
Okay. Did we start previously? Okay. Just open that. Share your screen. Sanjay.
Okay, are you sure? Give me control. Sure.
No, you can share this account.
Oh, okay, I can share. Okay.
Yes, I didn't share anything, so you can automatically share. Right.
Just let me know.
Yeah, that's me.
See, this is the association
Okay,
load learning.
association clustering we've done. Okay, reinforcement.
We have
Last thing, upper confidence bound and Thompson sampling. We didn't see that.
No, we didn't discuss
Okay.
about that.
Okay.
We discussed the a priori and
A priori and ECLAT. Okay. Open the coding for upper confidence bound UCB in reinforcement.
Optimization, CTR.
CTR is nothing but that is click through rate. That is ad performance. What is there in your screen, Sandhi? I am seeing something like it is hiding me.
Okay.
Something. First of all, we have to see what is called as reinforcement learning. First import the data set. Okay. So first we'll see what is reinforcement learning. Go to any tab, just type.
1 minute, let me add the data set.
Okay.
Okay.
Because it is big, that is why. Go and search for reinforcement learning from this medium. Reinforcement learning. Medium.com.
Not only, right?
In machine learning, no, medium. We will just take.
Oh, medium, okay.
Medium. In machine learning, in medium.
This one?
Yes.
For this site is not secure.
Come out. Go to any other thing. Ultimate master grade. Yeah. Yes. Oh, I think medium.com itself is.
Medium is open actually.
Okay.
But I'm not sure why. See, if I go to medium, right? Medium. site is not opening.
Okay, and I
Site,
will
can you check it?
Senthil,
Medium.com is opening.
Senthil, you are using office laptop?
Yes, yes.
Maybe there is a block.
Mm.
okay. I will do that. You can just close it. Okay, just let me
You
share.
did not carry your this thing.
The iPad is there. The Apple is there. Yeah.
You should open from there. Just quickly bring my UCB. Oh, it's there.
Okay. See here.
Sharing screen.
Yes, I'm sharing. I hope my screen is visible, right?
Yes, yes, yeah.
Okay. See, reinforcement learning. I think I mean, everyone is having some experience in playing uh, chess game or any other 3D games, especially gaming environment. Okay. There, what is happening in general? Maybe I just describe this scenario. If you first time you are just started learning or started playing the chess game in your PC or laptop or your mobile, wherever, in whatever the environment would be. For the very first time, you will have I mean, you will have the higher chances of winning the first game than the computer. Have you experienced it? This kind of, even any game, not only chess game, any kind of a game, even Subway Surfers, 10 years back or 5 years back, everybody is playing Surfers. So there is, to some extent, the player, will be, the user will be, winning against the computers, winning against the applications. Okay, so that means the first instances, it is trying to learn from its mistakes. Okay, that means the very first time you are playing against the, say for instance, chess. Your first time you are playing, the opposite, I mean, the computer is just not trying to analyze. Computer in the sense that is the smart system. It is inbuilt, and for the first time, it is trying to observe your every movement. For every movement, it is trying to analyze for the first time. It doesn't mean that it is it is intentionally um, just losing the game. No, it is not intentionally losing the game. For the first time, it is trying on its best um, on the smart system provided within the algorithm. It is trying its best, and also it is trying to learn best. That means it is trying to learn the user's best. So the next time and the next time and the next time, it will never, I mean, the winning against the computer, it is getting very very tough and challenge. Okay, I think you visualize this scenario. Not only chess game, you just play any other game. Even now, if you wanted to play anything, just download any application, even 2D or 3D games. Just download and do whatever, as a user, you're just trying to play. Um, for some games, you have some idea, and with that idea, you are playing, right? But for very first time, the computer will analyze your behavior, attitude, perception, and everything. And the next time, it will be very, very fast. The learning curve of reinforcement learning is very, very fast. That is why, some of the games not only the games. If you see any other situation with the same situation like this, winning against the game, it is like impossible, near to impossible. Okay, so it is an aspect of machine learning where an agent learns to behave in an environment by performing certain actions and observing the results, rewards, and results. That means the agent learns to achieve a goal in an uncertain, potentially complex environment. Okay. So from this algorithm onwards, we use the term called agent. Okay, so that means very soon we'll be jumping into agentic AI. That means, we are going in depth in this smartness. We are going to depth in the autonomous agentic autonomous process automation, and we'll do a lot of things. So that process automation will be doing very, it becomes a master in any kind of process automation. So in RL, an agent makes sequential decisions while interacting with an environment with the aim of maximizing a cumulative reward. That means if the computer is winning, or wherever the possibility of winning moment is there, it is getting rewarded. So rewarded in the sense in the computer terminology, in the algorithm terminology, rewarded in the sense it will just getting boosted. That means the potential is very high, the capability is becoming high, it's getting more charged, powered on. Okay. Maybe you can see this kind of a learning while you're watching the movie Robo. In Robo, this kind of a situation, you'll be the climax, the first part, if you see the climax, it is getting, learning and learning and learning, then it is getting more power and power. Okay, so the winning against that system, it is near to impossible. That is why that scene it's quite. This is it is getting rewarded whenever it is getting close to winning. Then it is getting rewarded. Rewarded in the sense it is getting more power, more automated things, more decision making things. When it is not able to able to make a decision in a perfect manner, then it is getting punished. Okay, so the reward, the opposite of a reward will be happening. So whenever it is getting punished, that potentially it is getting reduced. Whenever it is getting reduced, at that moment it started learning. So that is why results, rewards, results. Okay, so this is the first result, and then it is getting rewarded if it is in positive side. If it is in negative side, again the results is coming, and then again it is getting some kind of a input and learning, and all the punishments will be taken it as a learning curve for this reinforcement. That is why it is called as reinforcement. So it is again and again it is getting reinforced. So the learning curve is becoming more and more and more. So we never know that where it is getting rewarded, where it is getting punished, because it is ultimately the requirement is going to solve this problem. We never know that when it is going to solve, when it is getting reduced, the power of learning model. Okay, so this is some kind of to understand, but I'm not sure whether you'll be able to understand this figure. Just take a look at it. This is an input raw data, and this is it is getting into the agent, and it is going through the selection of algorithm, and the best action in this environment, it is getting rewarded, and then state is nothing but it's a decision making, and the agent is working very fast. But if it is getting failed, okay, it is getting failed in those kind of things, it is not yet portrayed in this image. So the output is, you can just see, it is just segregated like this. Okay. If it is getting rewarded in the sense, it is trying to segregate an information very fast. Okay. That means the star just putting into, the classifying or grouping it together, and then the squares, and then the other notations. So it is, it is very, very fast. That is why they are giving this. Okay. So what are the key components over here? So the agent, decision maker or learner. So this is how it is. Decision maker, if it is getting rewarded, decision making is fine. If it is not, if it is getting punished, then it is becoming a learner. Okay, so that is why the agent name is, the first is decision maker or learner. Environment, everything outside the agent interacting with it. So outside the agent, how it is getting interacted, how it is getting learned, and any environment you can just feed in. It will be able to decide, it will be able to work. So we'll discuss some of the examples. So action, what the agent can do, the choices it has. What all the choices it has, and so that it will make some action. State, the current situation returned by the environment. The rewards, the immediate returns and back from the environment to the agent in response to its action. So everything is based on the action, whether it is getting punished or whether it is getting rewarded. It doesn't matter. But if you just input this algorithm, the algorithm it will work like anything. It is very fast, and it is decision making is very fast, and the learning curve is also very fast. So it doesn't matter whether it is a learning or rewarded. It is, but it is very fast in both the things. It will be failing very soon, and it will also learning very soon. So that means every learning curve it is getting rewarded in future. Okay, so we'll see the information. So the agent's objective is to learn a policy, maybe find the value, which is the mapping function from states to actions. The policy determines the learning and decision making, telling the agent what to do at a given state. So what are all the things? What are the applications? If you see this, you will be knowing how the decision making has been happening. Game playing, this algorithm have achieved superhuman performance in a variety of games, including chess, Go. Go is an application like chess. Okay. And poker. Poker is, I think, one of the most played and playing games in the world. Okay, so poker, the ultimate performance is based on the reinforcement. AlphaGo, developed by DeepMind by Google. Okay, so this is also one of uh, the main reinforcement learning platform, defeated a world champion Go player. So that is this one, the Go player. It's just a win. And if you take IBM Watson, okay, so IBM Watson has the same kind of an application. That is also reinforcement learning. IBM Watson has a different varieties. Like they are into healthcare. I mean, Watson into healthcare, Watson into game, Watson into what to say, many platforms like software development, gaming development, and then this kind of a poker gaming. I mean, pokers. They were very famous in like chess games. The first ever.
Online rummy.
Yes, those kind of online rummy. Everything behind the scene, the reinforcement is there. So online rummy, actually the reinforcement learning mostly favorable towards the computer. Okay, so that is very inbuilt. The algorithm is fine-tuned uh, from the companies, I mean the enterprise perspective. It is not for the user perspective. Okay, that means the company will win more and more and more. That is what I mean. The initial stage, the beginning stage, they will be giving, they will be attracting by giving some money initially, bonuses, okay, product things, gifts, and then the people will get addicted towards that. Next, robotics. So reinforcement learning can train agents to perform complex tasks like walking, running, or jumping. So Boston Dynamics robots are great examples. Nowadays, robots, even recently, I mean, last week, Elon Musk introduced. Have you seen the video? Elon Musk introduced two or three varieties of robots. One is like a cab. Town is like a cab. Okay. They have just introduced to the world, and not in very soon. I think it will be used by the public. What are they saying in the recent? That's called a cab. Okay. Show you so that you will get more understand the visualization. Must visit management products.
It's kind of personal assistant, Sini.
One is personal assistant. One is on the the car, which is what is this?
He launched the robots, right? Robots.
Robots.
Yeah.
Yeah.
Now that can be told as Chitti 3.0.
Yeah, might be.
It was amazing. Yeah, it was. I saw the launch actually. Yeah.
Launch. You saw that, right?
The
So
name
the
of that
launch is
particular name also they have something like that.
they have given, yes.
Yeah.
Yeah.
So we'll see as a news. Let's see. So that you can just relate to the reinforcement learning, how it is getting reinforced. Yeah, this is the car. Some people see as a
The
star.
robot. The robot, the event.
Yeah, yes, yeah, exactly. The robot, that event name. What's this?
It was actually performing the hand gestures as well while speaking.
It was it was amazing. Okay, so it was amazing, and you can use it for bar. You just automatically it is just mixing. Okay,
Cocktail
like a
mixers.
bartender. Yeah, bartender. Right? In the
Yes.
bar, and it is just rightly mixed. It's very fast again. Those kind of robots has been. I think we can use it for home for elders, giving medicines on time. And, the other kind of a help, we can tune it so that it will be really helpful for them. And one more thing, that is one. The other thing is they introduced a car like Tesla, advanced Tesla, and this is not like Tesla. The model is different, and they are saying that it's a kind of a van. If you are traveling like 13 people or 14 people, like a share auto, right? So likewise, it is a very huge van, and you can just okay, sir, you have to just go and have a seat. That's it. So 13 or 14 people you can carry along. So what are they saying? You can use this automatic thing for public usage, especially for cab taxis. Okay, that is one. They introduced one more thing. I really forgot. So these two things, if we just closely look at the thing, the reinforcement learning is like playing a very vital role. Okay. So self-driving cars, yes, ultimately that is what we are discussing. So optimize the decisions made by autonomous vehicles to improve safety and efficiency. There is so much of reinforcement learning, we have used even in computer vision technology, even in deep learning technology, even text to text, even text to image, text to video, audio, everywhere. Okay, so even in large language models, these things are just working. And even in agents, that's what the agentic AI based on more of the applications based on reinforcement learning. So the online advertising, RL algorithms can decide which ads to display to users to maximize click-through rates, so CTR. So this is what the example it has been given for, in your data set for reinforcement learning. Okay, so the online advertising, even which ad should go first? Which ad should? I mean, every region. It is based on the geographical region. If you spend more and more and more for your ads, YouTube ads or Facebook ads or whatever the ad you are giving in digital marketing, it is taking, based on, the decision making is based on reinforcement learning. So there is so much of automation and it is working fine. That is why, some ads will be, some videos might be, very, very worst, but it will be having huge interaction with the audience. That means they have spent much, they have spent more money on those kind of an ad. So reinforcement learning just picking up and voluntarily, we able to see and watch those kind of an ads because they are already spent much money dollars on those ads. So YouTube or even Facebook or Instagram, they are just pulling or pushing those ads into top. So recommendation systems, reinforcement learning can help to provide personalized recommendations to users, learning from their past behavior to suggest relevant future actions. I think I have shown you one of the applications called Rabbit R1. Did I? Did I show the Rabbit R1?
Yes,
Yes,
that
yes.
small tool,
That
right?
is,
So if you
yeah,
want to
small
automate,
tool, the box type kind of a tool.
Box
Yes.
type. Yes, yes.
Yes. So that is also, based on the reinforcement learning. The main algorithm that is because it is continuously learning. And if you have the Alexa or Google Mini or whatever the smart devices, the voice assistant, that is also based on reinforcement learning. So wherever the automation or autonomous thing is happening, definitely reinforcement learning should be there because the learning curve for the application is very, very important for them to improve. Okay, so in those situations, you should have this kind of information. Right. So this is what is all about, the reinforcement. In this reinforcement, you can find two methods. One is UCB, upper
Upper confidence.
bound. Okay. So um, okay. I think you have seen this kind of. I think it would have gone in US. The what is that?
Vending
The
machines.
gambling. Yeah, not a vending machine. It is.
the newspaper
No,
stuff,
no,
right?
no. These are
No, no.
gambling.
Casinos, yes.
Gambling
In
game
casinos,
machines. Yeah.
in casinos, you would have seen, and in our mall in India, every mall is having Fun City or Game City, whatever it is. So in those games, you will be playing some of the machines like this, and you will be getting some reward points like a coupon. So kind of a receipt. So the receipt you will be getting and you will be just reimbursed with that receipt, right? The same kind of thing is happening everywhere, especially in casinos. They are working on the reinforcement learning. Mostly, it will just turning it as their favor of their side. Okay. Right. So the multi-armed bandit. Bandit is nothing but it is, what is bandit, right? So like bandit queen. Okay. So this article that we have five or more number of slot machines in which we bet our money in such a way that our profits are maximized. Every machine has its own distribution according to which your profits is determined. So we use the combination of exploration and exploitation techniques. This is where the upper confidence bound, the UCB concept is coming. The combination of exploring the product or services, and also we are just exploiting the product and services. That means one side is the learning. I mean, the exploration is nothing but learning is happening. The other side is we just become a kind of bandit for that kind of a problem. So we'll just exploit the system, okay, exploit the techniques, but it is happening in a balanced manner in order to increase our profits. If you are not balanced or if you are not playing well enough, it will spoil you. So that is where the gambling. We are calling this as a gambling. So first, the system will fail in front of us. This after that, slowly we will fail and we will lose our money. The system will exploit us, and system first explore us and then exploit us, okay, through their algorithms. So we cannot have only exploration or only exploitation, as they might not give us the optimal solution for our problem. So in that case, UCB is a deterministic algorithm for reinforcement learning that focuses on exploration and also exploitation based on a confidence boundary that the algorithm assigns to each mission on each round of exploration. So this boundary decreases when a machine is used more in comparison to other machines. Okay. So what are they saying? I just go to the code and then we'll come to this mathematical information. Just go to the code. I will just start with share. Stop share. You can share the code, the UCB code. Sandeep? Sorry, can you share the code?
Can you able to see my screen?
Yeah, I can see your screen, Sandeep.
No, I
Okay.
can see.
Yeah. Okay. So this is the
Yes.
importing libraries.
Okay.
This is importing data set and implementing UCB. Import
Just
math.
see that mathematical library, right?
N equal to 10,000.
Equal to
10,000.
10,000.
D equal to 10. Add selected blank number of selections into D. Sum of rewards and total reward. So 0 to N,
So
10,000 range.
here one question, Srini, in the fifth line, number of selections, if you see, in brackets we are saying 0 into D.
0 into D.
But that should change,
Always, so in our mind, the system, see, this is based on the number of iterations. So if it is 0, ultimately it is coming as 0. If it is 1, it will change. That is why, the color combination is just, giving us yellow. So it is automatically, built in while running the iterations. So, yeah.
Well, automatically, while running the iterations, it will change. That number will change.
Yeah.
Okay.
Yeah.
So by default, we are asking it to start from 0.
0. Our index position is 0, right? So that is also one of the reasons. So what we do, just to copy this piece of information, right, from import math. Yes, that block. Okay, yes. Yeah, wherever we are getting a copy and go to the plot and explain step by step, so that we'll reveal or we'll get to know the process of UCB, so that we will get to know the mathematical convention of UCB instead of getting the real mathematical application. That is for researchers. We don't want to do those kind of things.
Multi-armed bandit call.
Yeah. So it is called as multi-armed bandit problem. So bandit is nothing but exploiting information, exploiting money, or exploiting anything. Okay, so this is just a bandit problem. We are,
Hello.
the mission. If you see, I think,
Srini.
have you been there in those
For sure.
casinos in the US?
Which one? Casinos, Srini?
Casinos. Yeah.
Casinos, yeah, we seen, yes. We seen, but not played, yeah.
Okay, okay. Okay. I have played in
Oh, okay. Poker game?
New Jersey. Yeah, in New Jersey, there is a big casino.
Okay.
Park or something. Yeah, so I have been there for the whole night. So I have played,
Okay.
I have spent, and I have got something.
Okay,
But
okay.
that is a different world, and
It's a mind game, like it is always, it is not online or something. So you are playing something in the board, right? So you
yeah,
will.
board game. I played more on board games and other things. Actually, it is a mind game, but we never know what is happening. That is where the clue is. Okay, so I have spent more than $500.
Wow.
500, yeah, $500, more than $500. I
Mm.
got more than $1,000. End of the day, I just left around $1,200 or something. So but I never recommend for anyone to be there.
వాయిస్
You can
బ్రేక్
just
అవుతుంది
enjoy.
చాలా. నేను ఇప్పుడు మీటింగ్ లో ఉన్నా, ఏదో ఒకటి తీసేసుకో.
Right, yeah. So this is math application, math library. Okay, n is set to 10,000, likely representing number of arms or adds in the context. So in our data set, just open the data set in our click-through rate data set as a CS, I mean Excel sheet. No, not here. We can't open over here because it is huge. Yeah, there are 10 columns. It's like adds 1 to adds 10. There are only 0 and 1. That means whoever is clicked the ad, not click the ad. So 0 is not clicked, 1 is clicked.
Okay.
So this is what the representation. Okay, so whoever is CTR means click through rate. So this term is very famous in digital marketing and especially marketing. So that whoever is seeing the ad, how many people clicked or how many people just crossed, because we are always swiping our the mission, I mean our phone, right? So through that you are just getting some sponsored link. If we are interested, then we will click. If we are not, we don't. Okay, so everything does matter, but we are thinking that we are just crossing, but actually whoever is just making, I mean spending money, they will have the track record. That means how many people we have been reaching out, and how many people just clicked after reaching out, and whoever clicked that link, how many have actually paid for that ad. That means maybe in that ad, paid ad would be there. When paid ad means you have to, maybe you are just looking for course and you are paying to for the webinar or something. It could be any even product, maybe very less product, less price product or something like that, right? So everything has been tracked, and everything. Well, in those cases only, this reinforcement learning is playing a vital role. So if you take any kind of a e-commerce portal, this is playing a very great role. I mean, both consumers and also the manufacturers or whoever is selling their products. Okay, yeah. Come to the article. Yeah, code. Yes, the plot. Right. So D is set to 10, likely representing the number of arms. So this is what we have. That means adds 1 to adds 10. We have this many arms. Okay.
Correct.
Now initializing the data structures. So ads selected, it is just empty. Come down. Yeah, a list store which ad was selected in each round. So in each iteration, which ad is selected. So number of selections, a list to keep track of how many times each each ad has been selected, number of selections, and then sum of rewards, a list to sum up the rewards received from each ad. That means each click is getting reward. It is not just a swiping the your timeline or something. You have to click. If you click, it is getting rewarded. So that is why maybe accidentally or instantly or unfortunately or fortunately, if you click any ad for the next 2 or 3 days, you will get so much of information regarding those kind of type of ads. You would have experienced this kind of thing. So that means the system is trying to learn you, and then they just pouring those kind of information until you don't want to see. I mean, after 2 or 3 days, if you are not clicking those kind of ads, it won't come to you.
This is specifically, you will see this more frequently in Insta ads, Facebook ads. So the kind of people you follow, the same kind of ads you will get. Also, when you scroll through your reels, the more number of times you stop for a reel, like without scrolling, it will understand. And then next time when you see the reels, all those kind of reels only you will be able to see.
Yes. Obviously, this is what kind of it is trying to learn. Are you that kind of a person? So that is why nowadays cyber security, even police, I mean those kind of cyber security people, if they just trying to see your social media thing, then they will immediately study your attitude, behavior, and that is also one of the factors to redefine the crime, or it is playing a vital role to identify you know, whoever is just made those kind of crimes. Okay, so that is very. And then total reward. So we are able to keep track of the total reward across all rounds. So each and every iterations, it has been stored in a total reward variable. Come down. Yeah, the main loop, it is for loop for n in range of 0 until n. It starts from 0. It is not starting from 1 because 0 also counted over here because of indexing of title. Okay. So this loop runs for n rounds until the 10,000 in this case. Okay. So selecting the add equal to 0, the maximum upper bound is 0. For I in range of 0 and b. So in each round, we initialize variables to find the add the highest upper confidence bound. Okay. Still, we need to identify what is the highest upper confidence bound. We are not sure that in this information, what would be the maximum value of this upper bound. Come down. So yes. So calculating the upper confidence, just to see whether you will be able to understand the the maximum upper confidence bound.
It's like infinity kind of, so
Yeah.
maximum number of, it is infinity kind of. Very high upper bound. If the ad has been selected before, we set a upper bound to ensure it gets selected.
So what are they doing? So would you be able to yes, if not, you can ask one more question like, how the maximum or upper bound has been selected. Yeah, this upper bound, that is the maximum value. Um,
How?
how this has been selected. I think they have given some input in sixth element, sixth point. Let's see that. Yeah.
Extremely large number. 1 followed by 400 zeros.
That much chances the system is giving for you, giving for the data set, so that nothing can be left out. Okay, so it's chosen to be effectively infinite in the context of this algorithm, especially if you just see read the purpose. The goal is to ensure that any arm that has never been selected before, and it will be chosen next. So that is why we are giving the high upper confidence, bound, the maximum value.
Which means like it is for the ad poster or something like if I miss the ad the first time. Okay, so any of the point, like if I in touch with the face, for example, take example of Facebook, I open one reel. So suddenly one or any video I'm opening, suddenly one video came and I just ignore and move on to the next one. But that particular ad will contact me again in another way opening the video again. You mean to say in any part of that particular process, the whole
Yes,
day.
not only one person as Sendil, maybe Sai, maybe Srini, maybe any person. It will just throw some kind of an input to every individual's records. Every individual timeline. So that is why the click-through rate, if I am not clicking in my region, maybe the same ad will be, and because this iteration is getting over, my iteration is getting over because I'm not clicking. It just goes to Sendil immediately because Sendil might need, that is what the system is just giving you. And I will just give you the example. Okay, if I spend, okay, just to give in the cloud itself. Per day, just type per day I'm spending. Okay, I'm spending. Okay, I'm spending 1 lakh per day. 1 lakh per day for my AML training. AML training on Facebook. What is the probability of getting valuable leads? Getting valuable leads for 1 month. That means 30 lakhs I'm spending. Okay. But it will give, yeah, come down. It's a significant budget it is giving. And then campaign duration, 1 month, fine. Target audience, whatever it is, yeah. It depends on it is giving something, okay. But because it is playing very safely, okay, come down. But if you ask the same question to Google Ads or ChatGPT, it's giving you along with another, yeah. So monitor key metrics like click-through rate and everything is given. Okay, so we'll be getting, yeah. See, in my experience, my calculation, if you are spending 1 lakh people, it will be reaching like 2 lakh people. But the click-through rate, that is the lead. Okay, the lead is 5% of that click-through rate. That is the digital marketing perspective. 5 to 7%. That's it. It's very, very low. That means 2 lakhs people, I'll be able to reach within a day. That means in that 2 lakh people, 5%. Take the 5% from 2 lakhs. Solid lead. That is actually a very good margin if you spend 1 lakh. So that is called as another term called law of large numbers. Okay, in digital marketing, law of large number is working like anything. Okay, so we'll discuss on some other time. Okay, so this is what it is. It is just trying to reach out people, as many people as possible. That is why Facebook is becoming one of the huge portal, and everybody is coming for selling. And even for each and every word nowadays, AI ML getting a lead, you have to spend like anything. Otherwise, you won't find a lead, because every nook and corner, people are pouring ads like anything for AI ML. Even products, services, training, education, coaches. There are so many boundaries. There are so many classifications, grouping. There are so many people, organizations. They are, so AI is a competitive keyword right now. So what Facebook will do? They bid for. Okay, so they say, okay, this is the highest amount. You people, among the crowd, you decide, and that is how the Facebook will bid. That means Facebook means the system, the reinforcement learning system, just a bit for this kind of things. So if I'm just targeting for 1,000 rupees per day, I will get only 10 or 20 people as in, because it is very, very less, because it is very competitive, highly competitive, it is very crowded. So you have to spend like anything, then only you will be getting lead from Facebook.
Well, the reach will be differentiate by spending, right? So if I'm spend
Yes,
1
yes.
lakh, you can reach 10 lakh people.
More than 2 lakh, yeah, more than 2 lakh, or even 5 lakh people also, you will be reaching.
If I spend more than what is that lakh, so for example, I'm spending 2 lakhs, so I'm getting
Hmm.
what is the reaching of 10 lakh people. So that's how the what is that market segmentation for what is that ad that Facebook ads.
Mm-hmm. Yeah. So
Mhm.
that is how we have to calculate. And even Google is very high, but
Mhm. Even
differentiation
for
of
this one,
leads.
no, this customization, like see, for example, whatever the things you type in Google, the first thing will come appear in your search, right? Search engine optimization.
Yeah, yeah, yeah.
So
SEO
that is
is.
actually you have to pay what is that more actually compared to the other thing, right? So this is
Yeah,
same way it will work for the this market as well. So
yeah,
reach
yeah.
and all. Mm.
Yes. So these are all the some of the thing you will be able to visualize. Okay, so you'll be able to close to the your heart. You'll be able to visualize how reinforcement learning. Okay, so go again to the code. Go up to see the go up, like this algorithm balances. Okay, fine. Okay, so sixth point, yes. So selecting the upper confidence bound, you can set the date and okay, yeah. If upper bound greater than maximum upper bound, and maximum upper bound equal to upper bound, and add equal to I. So we keep track of the add within the highest upper bound, so that it is always getting the maximum upper. We'll just compare the maximum upper bound. I mean, the upper bound is always greater than the maximum. That is what the updating the statistics. Yeah, these are all some of the, we record which ad was selected. We increment the number of times this ad was selected. We get the reward for this ad from a data set. All right. So we update the sum of rewards for this ad. So this algorithm balances exploration and exploitation. I've been trying ads that haven't been selected much, and exploitation, selecting ads that have performed well in the past. So the UCB formula ensures that all ads are tried a sufficient number of times while favoring those that perform. So if you see the Facebook and YouTube, which has they're having maximum subscribers. The Facebook nowadays, it is very, very crowded. Instagram, they're too much crowded. Billion population is there in my Instagram, and YouTube equivalent of that people accessing YouTube. That is where they introduced Shorts. Shorts is basically competition for reels, because reels is getting famous. So that is one within a minute, within 60 seconds. Not only is it 60 seconds, it's a 0 to 59. So 59th second, you will be decided whether the people will continue to watch or continue to buy your product, continue to buy your service, and the decision making just within 60 seconds. That is why the attention span of the user nowadays it is only 10 seconds on an average. If within 10 seconds you are not attracting a people, you will get swiped. That's it. So whatever you are spending, nothing. So that is why the ads are very, very curious. Even see the earphone, what he has done today or yesterday. It is ridiculous. And they have done for just for the likes and the other things. Okay, so that much, the extent people are, ready to go. So, I mean, that is not a product or service, but it is like, the same kind of thing is been, happening through this kind of a social media. Because, it has been crowded and people are doing just because, always there has to be a talk or discussion for them. So that is why, we are doing some kind of unique items or unique activities or attitude or behavior, so that they will always be in top of the town or top of the town, whatever it is. Okay, so this is one of the information which we are taking from the UCB level. So this is what is all about, in reinforcement, and we will be selecting how much ad you are giving. It doesn't matter how much the click through rate for that getting the CTR, how much we are spending, and all the rewards, is been getting stored, and it all depends on how much you are spending per ad. Because if you are spending very low, you will be reaching very low people. If you are spending high, you will be reaching high. So for that, for automating this process, Facebook and everybody they are using uh, reinforcement learning. Okay.
And how
Right.
they differentiate with the premium customers? Like, for example, YouTube Premium, they don't have any ad section, right? So a non-premium only, they will show the ads. So in that case, I think how they will differentiate, like how they want
No,
to reach the premium customer also, how they filtering it, how they want.
even see for premium customers, it is very compared to the crowd. Say for instance, one crore people is there. Just for example, 1 crore subscribers. Within that 1 crore, only 5% they will be a premium customers. That's it. They don't bother. They are giving because they are paying, right? So for the rest of the 95% of the crowd, there are so much of ad campaign is running. If you are just trying to watch any video, 30 seconds ad is there, 10 seconds ad is there, 1 minute ad is there. You can't, cut those kind of things. You should watch until the end of the video appears or the brand value appears. I mean, there are so much of methods are going on. It is not only from the user perspective, we never imagine, but in the business perspective, there's so even Spotify, how they are. I think look at their ads nowadays. They are reaching out like anything. But in India, they couldn't, get more subscribers because we are, free consumers. But still in India, they are getting more ads. That is what the system says. That is what um, the
Because we
article says.
reinforced to watch ads, right? So in
Yeah,
previous
yeah,
days and
yeah.
all, many
Mm.
ads I think we are forced to watch. So people are sitting watch for half an hour. I remember, like,
Yeah,
so
yeah, yeah.
they are used to it, and they don't want to go into the premium thing by paying some rent every month, right? So they just okay.
Yes, yes.
I'm watching that's 20 minutes, 30 seconds. That's fine with me. I'm skip the ad and will watch it. So I used to that practice. That's why it's very difficult for them to convert into premium subscriber. So in India,
Yes, yes.
especially in India, because we are reinforced to that ad section.
Mm, mm. This are the things.
Okay.
Okay, this is one. So this is that's all the ad is. I mean, that's all the program is. Then next is, you are just
This is
visualizing the
the very standard procedure, Asini.
yeah,
This is
standard procedure. Yeah,
just apply
just
this method
apply this technique. Yeah. Mm.
and just visualize the result.
Yes, it's very very simple method. So
Mm.
this effective and potential method. See the yes. So ad selection
Number of time each ad was selected.
is selected.
Histogram of ad selections.
It is like, four, so 6,000 or 7,000 times it has been selected within the range of this fourth. The fourth ad,
Fourth ad,
the
okay.
fourth ad, it has got selected this much time.
That
So
means it has some attention.
yeah,
That
attractive,
mean,
attractive content. Yes.
okay.
Yeah. Tomorrow we'll see the other one.
Okay.
We are ready to go on deep learning methodology.
Okay, this one is upper conference round,
Upper
right?
bound. Yeah.
And
Next one is Thomson sampling. So this
Thomson. Yeah. Thomson sampling.
Yes. It's very easy. The same.
Okay.
Because Thomson sampling it's a random selection. It is not one kind of thing. Just to open the code.
Same
ad only. Same data. Data points are same. There's not much difference between specifically sampling is random. So previously we have done with the math algorithm. This is for random algorithm. So import random.
So,
This
random.
based off
This
the
max, this is random.
Yeah, that is the only difference because it is applying for the random selection process.
Okay.
So the random selection also the same kind of ad, but the ad is come down. The ad is different. The same thing. Yeah. But it's more than 8,000 or 10,000 randomly, the user has been selected.
That means instead of outbound, like we are fixing, right? So here it is randomly selected the output. You mean to say it's a random bit or maximum random. So if you go with this, what is that? UCB. Here, instead of math, random procedure like we follow, and the same way, the maximum upper bound here it is here we mention anywhere.
You can also do the
upper bound
between the two codes. You can also do the comparison between the two codes in Claude.
Oh, really? Okay.
Yeah, you can do. Where are the codes changes and what is ask them, give me in a tabular column, it will give wherever the code changes.
Yes, then. This is the upper bound conference. This is the
Random.
So this is maximum random. So wherever it is upper bound, it is random. So it is randomly select the upper bound. You mean to say?
Yes. Yeah.
So here we are not giving any upper bound value in Thomson sampling. So that's why we put a random thing. So it's randomly select that upper bound. That's why maximum random it gets selected.
Yeah. You can just ask the same question. What's the difference between the UCB and constant sampling in what is the difference between the UCB and constant sampling?
Reinforcement learning.
RL.
So, okay. Stop about. This is the probabilistic approach. So it's now the highest sampled value. It's in the face of uncertainty.
So wherever you are using random, ultimately it has been going for the possibilities and probabilities. So the probabilistic theory is getting applied with example.
Same only.
The charge between US UCB and
it is asking subscribe. That's why it's not correct. This is very, I think, not even 5 questions. So immediately ask to subscribe.
ChatGPT is far better.
Yeah, these people.
But the cloud is really amazing on very right approach. It won't give a lot of stories. It's very straightforward. That is why it is this algorithm is really this LLM is really nice.
Okay. So you mean to say they have very good training models? That means they train.
Yes. Yeah, cloud is really very highly competitive, I would say.
But out of all LMs, I think you recommended like ChatGPT is a very fine-tuned one.
ChatGPT, yes, fine-tuned, but for some cases, some use cases, cloud
is better than
better than ChatGPT. Yes, there is no question about that. But again, if you compare in general, ChatGPT is working on small, on top of it. Because they have already billions and billions of text got trained. They have a huge model, tested it very well. Their structure and approach is different than any other LLMs. So that is why they can now see the Sam Altman. It is they don't want Microsoft intervention anymore. So that kind of a decision has been made, day before yesterday or last week. So they have come to a conclusion that wherever Microsoft stops their decision making, they should stop. So they don't want all the interfere in their companies and process. So that means it makes a lot of sense for the investors and other people.
You mean to say the OpenAI?
Yes, OpenAI.
Okay. Okay, Sini.
Okay,
so we will see tomorrow. A little bit.
We'll see a little bit about this, and then we'll start the other topics.
Sure. Yeah.
Okay.
Thank you, Sini. Same time tomorrow or different time?
One second. Same time. Let me check my calendar.
Yes, please.
6 o'clock. Yeah, same time should be fine. Before this also is fine for me.
Okay.
4 o'clock or 5 o'clock is also fine.
No, until 5:20, I will be busy. 5:30 or 5:45 will start.
Yeah, 5:30, 5:45 should be
5:30,
fine.
right? Okay.
Yeah, yeah.
Right. Okay. Thank you
Thank
so
you.
much.
Thank you. Yeah.
Okay.
Bye.
Bye.